Well, we're next going to do a quick review of the motion capabilities within SolidWorks. So we've looked at measurement, solid mass properties, we've looked at interference. Here's one of the really interesting utilities in SolidWorks. Now, we already know we can take a model and just drag it around and observe the motion that occurs as a result of the various mates, whether they be geometrical mates or mechanical mates, like we saw in the case of gears. So we're next going to look at a series of utilities in SolidWorks that allow us to move the model in a manner in which we can better display it. Okay, so that would be for purposes of visualization, for purposes of better communicating the design, its nature, its capabilities, etc., to an audience, and also to do dynamic analysis. Okay, so both from the perspective of how good something looks, if you will, and also from the standpoint of how it performs from an engineering perspective. So here we go. Now, quietly here down at the bottom, we've had this tab labeled Motion Study. So let's go ahead and click on it. That's our access to a variety of animation, all the way from simple animations to very sophisticated rigid body dynamics type of analysis that we can do in SolidWorks. Now, depending on the specific version of SolidWorks that you have installed, you would have access to animation and basic motion, so that would be part of the core SolidWorks, as it's called. And if you want to do the more sophisticated rigid body dynamics, then you would have to invoke one of the SolidWorks add-ins, specifically the SolidWorks Motion in there. So let's go ahead and turn it on now, and as you turn it on, you'll see that it becomes an additional option here in the drop-down menu. And there we have it, motion analysis. Okay, so let's go ahead and create probably what could be the simplest example of motion here, which is a straightforward animation. We're just going to take our model and we're going to see how it behaves in between any two given points. Okay. Now, animation works on the principle, and motion in general, works on the principle of keys and keyframes. So right now, we have these diamonds here, which are keys. We're sitting at time 0, and we have this time bar here, symbolized by the orange vertical line. And what we're going to do is simply drag this time bar to a new time. Here, say for instance 2 seconds in there. Now we have to have this auto key. Normally we have that auto key in place. And now when we drag any components in the assembly, we'll see that a time frame is created that reflects the motion of those particular components. In this case, it's the crank subassembly, and of course the associated mates that have moved along with it. And we have that occurring at 2 seconds. And all the animation engine is going to do within SolidWorks is interpolate linearly between those 2 points in the assembly. Okay, so if we hit the calculate button there, that will go through all the steps, and now we can play it all day long. We can play it faster if we'd like, so we can come here to the speed, so we can play it at twice the speed. We can even loop it here, so that's the normal playback mode. We can put in a loop or even reciprocation. Okay, and now it'll go back and forth all day long. Now, in addition, we can also change the orientation and the view, and it is turned off here by default, but we can right-click on it. Okay, take off that option, and in this case, for example, come over here to point number 2, and very simply move the visual orientation of it. Okay. Notice that in doing that, we're creating a new keyframe now that involves the orientation and camera viewpoint. Okay, so we can now calculate. Okay, and notice how we can achieve both motion of the components as well as the motion of the camera. We could do the same thing with the lighting. This can get rather sophisticated. Okay, and of course, this is all happening at twice the speed. We can showcase our model better, perhaps, if we go slowly. Now, when you go slowly, you notice that you can see the individual frame-by-frame effect. That is controllable. You can come to the properties dialog here. So this is this button here all the way to the right, and the motion study properties in there will allow you to control the numbers of frames per second, so we can crank that up, say, to 30. Recalculate our analysis, and you'll see some rather smooth motion there. Very eye-pleasing. We can also save this as an animation file, so clicking that will enable us to create an AVI, a movie file, or a series of bitmaps or targets. That's a still image format. Well, let's crank up the fun a little bit here and move from animation to basic motion here. Now, in basic motion, we have the ability to add motors, actuators, to our assembly. And in doing that, we'll be able to achieve autonomous motion, if you will, of the assembly, and also be able to do some fairly interesting kinematic analysis. Okay. Let me first begin by taking these keyframes in here, deleting them, and I'm going to go ahead and add a motor here, and I'm going to add it. Okay, it's asking me first of all if I want to add a rotary or a linear motor. Well, what I want to do is move the crank in some automated fashion instead of defining its motion by the keyframes. Okay. So I'm going to select the component. Notice that I get by default an arrow there symbolizing the direction. Of course, that's changeable, and you can also define it by other means. And notice here that under motion, we have the ability to do constant speed, but we can also do a fixed distance, oscillating, so sine, cosine type of thing. Okay, defining discrete segments, even creating a data file, perhaps even an experimental data file, from some physical platform that we can then feed into the model to see how the model behaves, and yet others. We can insert mathematical expressions. Really, very, very rich set. Let's go ahead and stay with a constant speed. Okay, let's do 100 RPM here. So that would be just a very basic, type of constant motion, constant rotary motion for this device. Okay, we'll say okay, and that by default, that creates a keyframe in there where the motor is actuating over the span of 5 seconds. Okay. Well, really, without further ado, let's go ahead and calculate. And you can see that this is what it would do over the span of 5 seconds, going at 100 RPM. Now, this is playing. Of course, we have it all now with the previous settings. So we have playback in reciprocate mode. Let's go ahead and put it in normal. Let's go ahead and put this under 1 times and go ahead and replay it again. Okay, so that would be approximately 100 RPM. For this particular configuration. If we don't want it, quite that long, we can shorten it to 2 seconds. Okay, recalculate. Okay, and that's what happens over 2 seconds. And then, of course, everything else that we talked about, we can change the location, we can change the lighting, the cameras, the orientation, etc. Okay, we won't worry about that right now. Now, one interesting feature to insert at this point is the ability to do on-the-fly interference detection. Okay, so whereas before we were able to do interference detection in a, let's call it a static manner, so however, in whatever configuration, whatever form the assembly happened to be in, okay, when we click interference detection, we could get a listing of anywhere where there was a sharing of val in between 2 components. So can we do that at the motion level? So this would enable us to catch potential interference between components that might only come under interference under certain conditions. So in this particular instance, we actually have a purposeful, for purposes of illustration, a purposeful interference between the 2 yokes. And you might have caught it, if you go back to the previous example, you might have seen this interference between the 2 yokes. And so notice there how there's not a differentiated line, edge line in between the components. That's because they're coming together. And in fact, there is. If you were to do a static interference on this assembly right now, you would see it. Okay. However, if you happen to be looking at this assembly, say for instance in that position, you might miss it. Okay. So motion in combination with interference detection can be a powerful tool, and we can take advantage of that right now. Probably going a little bit too fast, for our purposes here. So we're going to drop this. So we'll go ahead and edit motor feature, say down to 50 RPM, perhaps even smaller or shorter than that, 20 RPM. Let's say. Okay, so let's go ahead and run the simulation here. Okay. Of course, since I had my keyframe enabled, it also did the zoom motion. Okay, so I guess we can tell it to behave here somehow. Okay, I guess it's still going to move for us. Well, if we're going to do that, let's go ahead and do it all the way. Okay, and there we go. The software has the ability to turn on the check interference feature. Okay, so if you right-click on the assembly, you say check interference. Okay. You can actually ask the software at each and every frame that becomes generated, and remember that this can also be adjusted, by the number of frames per second. So it's a combination of the speed of the simulation and the number of frames per second. Okay. You can selecting here the parts to test. In this case, you probably want to do the whole assembly, but only specific parts. We know that we're looking for interference between these two yokes there, and now we can see. Okay, there's some other parameters, start frame and frames, so 33 frames altogether. Okay, find now. I'll click, and we get a list of all the places where there was interference. Okay, and at each one of these, we're actually getting an indication, small as it may appear, of where the interference occurs. Of course, if we blow it up, we'll see that that's SolidWorks, being nice to us and telling us, where the interference is happening. And of course, that's where it is. So now you would know to go back and possibly edit the thickness of these walls, and then you might also want to do a check, that you haven't done anything bad from the standpoint of strength of the part. We'll talk about that in a subsequent video lecture.